Hello everyone, so in this video, let's talk about a problem from LeetCode. The problem name is get equal substrings within budget. So as you can see, you are given two strings s and t of the same length and an integer max cost. You want to change s to t. Now, changing the ith character from s to t required the cost of the absolute difference between the two characters that you have chosen. So you want to convert, let's say, s to this the first character to the first character of t. What is the absolute difference between them? In the ASCII differences, okay? That is the actual cost that you will incur. You have to find out the maximum length of the substring of S that can be changed to the same corresponding substring of T with the cost less than equal to max cost. The thing is that you are given some max cost as well. So you want to change S to T. Now, it can also happen that you cannot convert the whole string to T. Why? Because you have a constraint on the max cost. You have some cost with you. So the thing is, what is the maximum length of the substring that you can change from S to T? Now, whenever you need to find out some sort of a substring or a given string in such a way that you have to maximize the substring, then one of the very good technique which comes to my mind is you have a substring. So it has two pointers, the left and the right, which act as a window. So you want to just maximize the window length. So that's what we're going to do here as well. We will be using two pointers here. Let's see what we can do using two pointers. Let's take this example. The first one only, A, B, C, D, and you have to convert it to B, C, D, F. Okay. Now what you can do is that you can put two pointers. You will put one pointer here and one pointer like again also here, like the left and right. Both of them are pointing towards the first character. Now what you can do is that you want to first change the first character. You want to change the first character, which means that how much cost it will take, like absolute difference of A minus B, which is 1, because B will be 2, A will be 1. You can just say it will be 1 only. So you have incurred a cost of 1. Now you will always check that whether the cost you have incurred up till now is less than max cost, because you only have this much. So if you change this, which means that you have done one of the changes, then you can move one of your pointers from here to here, which means that you have now making this as a substring. The first one is done. Let us now check for the second one. B minus C, again 1, because 1 is occurred. So you will again, you can take that change as well. So it means that you have now make a substring of length 2. So at every step, you will keep on checking that whether I can take it inside the substring or not. How you can check it? I can only take it if I take it, then the absolute difference between them plus the absolute difference till now. The absolute difference till now, maybe I can store in some total. The total cost till now. The total cost till now is like from left to right, whatever cost I have incurred till now. Now, if I want to add this in the total cost plus the total cost it will incur to change from this to this, that should be less than max cost. If it is, then you can keep on adding this in the total and keep moving your pointer to the right. Sorry. So what we can do here is now that this is also good. So what we can do is that I can move my pointer to the next again. This is also fine because C and D again 1. So this is also fine. So as you can see, the answer is 3 only. Now if I try to add the next character, because the total has become 3 as of now. This is D and F, which is equivalent to D, E, F, 2. Now I have to add 2 in the total. So my total till now is 3, and the max cost I got is also 3. That is fine. But if I want to add this as well, then I have to somehow now move my left pointer towards the right hand side, so that I have to now smaller my window to include this in the window. So that I have to now, like, obviously because to add 2 I have to subtract 2. I'm just imagining that, but in real world, what you can do is that you can take this, and because you're moving towards the right, the total cost you have done, like the total cost of the window that you have is 3. So if you keep on moving this towards the right hand side, the total cost of the window will decrease. By how much? Because the how much cost it will take to add this one. So because you are not adding this in the window, like you have to subtract 1 from the thing. So this will be in the while loop. You will do a while loop over, let's say, this left pointer, such that to include this in the new window, that will be okay. Okay, and you now have to just maximize it over all the windows. Okay, this is just a standard two pointer problem. Okay, if you have more doubts, you can mention in the comment box. I'll move down to the code part now. This is the maximum length that I can get over all the substrings that I actually can maximize. Current cost is the current cost of the window that we have. This is the I. I denotes the left pointer and J denotes the right pointer. So I is 0 and J pointer I'll move from 0 till the very end. Now I have two options to include J or to not include J. How I can check whether I can include J in the window? I can include J in the window if the current cost till now plus if I'm changing the Jth character, like, which is the right pointer that I'm moving, if that is within the max cost range, then I can take it. So if I can take it, I will like increment my like current cost as well as like you can say maximize the maximum length of the window that we have. Else, if I cannot take the rightmost or the jth pointer inside the window, I will do a while loop. So because I have to first increment j because I want to take it in the window. So I will take it in the window and now keep on subtracting from the left hand side such that the window now again become less than max cost. So I will because I have to take jth. So this means that I can easily take j. This means that I cannot take j. I have to somehow move my left pointer. So I will first take j and now do a while loop from left to right, moving the left pointer such that it should be less than equal to j because both I and j can become equal. That is why I and j can become equal. So it should be less than equal to j. And if the cost is greater, if the current cost is greater than next cost, then only we can keep on moving my left pointer. So if the left pointer is moving, I'll subtract whatever the left pointer value is and keep on moving my left pointer. This is a value, and this will keep on adjusting the size of the window. At the end, we have the maximum length. That's the complete logic of the code part. It's just an O of N solution. If you still have any doubts, you can mention them in the comment box for this particular video. I will see you next one. Till coding and bye.